Calculus is more than just a number and equations. It's a powerful tool used in real life. In this project, we use calculus to analyze business cash flow through maxima and minima, and to solve a running problem using related rates.
Ms. Lou, can you get me the sales report and the cash flow summary in the past 2 years? Thank you so much.
So here's a graph of his business cash flow in year 2. His profit decreased during the first year, reaching a minimum of 49,000 at year 1. The profit function used is the P of t equal to t squared minus 2t plus 50, where the t represents the number of years and the p of t represents the profit. To understand the cash flow in year 3, we will use the profit function P of t is equal to t squared minus 4t plus 60, and to determine whether the profit is increasing or decreasing. First, we will find the y-intercept by plugging it t is equal to 0. So p times 0 is equal to 0 squared minus 4 times 0 plus 60, that is equal to 60. So the initial profit is 60,000. Next is the x-intercept. T squared minus 4t plus 60 is equal to 0. But in this equation has no real solution, so there is no real x-intercept. Now let's find out when the profit is at its lowest point in year 3. So first, we took the first derivative of the profit function. P of t is equal to 2t minus 4. So we set it to 0 and solve by 2t minus 4 is equal to 0. So the number pole, we would transpose it and divide it both sides to 2. So makakancel yung 2 and the answer is t is equals to 2. And for the second derivative, p of t is equal to 2, which is greater than 0. That means that the graph is curving upward, so the point at t equal 2 is a minimum. So now we will plug the value of t from the function. So p times 2 is equal to 22 minus 4 times 2 plus 60 is equal to 14 plus 60 is 74. Now we have the maximum point of 2 and 74. And here's the comparison for the year 2 and 3 that we will see his business is increasing.
So based on this graph, our profit with the second quarter of the 2 years, that's our maximum point. We can use this data to make better decisions moving forward.
Two friends, Rhea and Aline, start running at the same time from the same corner of a park. Rhea heads north and Aline runs east. Rhea runs north at 3 meters per second, while Aline runs east at 4 meters per second. And we want to find how fast the distance between them is changing after 5 seconds. Since Rhea and Aline are moving at right angles to each other, we can form a right triangle. We can solve for their positions. Rhea's position, let x be equal to 3 multiplied by 5 equals 15 meters. For Aline's position, y equals 4 multiplied by 5 equals 20 meters. So we have z is equals to the square root of x squared plus y squared. So substituting it will give us z is equals to the square root of 15 squared plus 20 squared is equals to the square root of 225 plus 400, and will give us the square root of 625 equals to 25 meters. So now that we already know the distance between them, we're going to solve how fast that distance is changing at that exact moment. We're going to use the related rates, and we'll start by differentiating the Pythagorean theorem with respect to time. So z squared is equals to x squared plus y squared. We differentiate both sides with respect to time. So we have 25 dz over dt equals 15 multiplied by 3 plus 20 multiplied by 4. We have 25 dz over dt equals 45 plus 80 is equals to 125. Next, we divide both sides by 25 to get the dz over dt. So dz over dt is equals to 125 over 25 is equals to 5. Therefore, the distance between Rhea and Aline increases at 5 meters per second after 5 seconds. Calculus helps us understand how things change. It shows how fast something moves when something reaches a maximum or minimum. From business to science, calculus is everywhere, helping us solve real problems in daily life.